the slide is 7 stories or 23.1 meters high with an angle of 60 degrees, we can start by breaking the slide into two parts. The physics behind a water slide is much more complex, but for our purposes we can just break it apart. The first part is 6 stories or 19.8 meters with a 60-degree angle. We're going to find the distance traveled. The second part of the slide is called the exit flume. This is the straight, flat part of the slide with a small amount of water to slow the rider down. I estimated that the exit flume is about 50 meters. The remaining height of the slide is 3.3 meters. Using these distances, I can find the angle of this part of the slide. In this movie, they were assuming a heavier rider would have too high of a velocity to stop at the bottom. Right away, we can debunk this myth because mass does not affect the velocity of a person or object. To find the velocity, we can use mgh equals 1/2 mv squared. The masses already cancel out, proving the movie is wrong. The potential energy at the top of the water slide is the same for every single rider. The final velocity we found is 19.7 meters per second. Both the rider in the YouTube video and the rider in the movie would have this speed. We already know the movie is wrong, but now let's answer what the coefficient of kinetic friction would have to be on the bottom of the slide for the lady to carry the type of velocity she does to break through the wood. To find the velocity it takes to break through a piece of wood, I had to make a few assumptions. After doing some research, I found that a speed of about 5 meters per second seemed accurate. I then can calculate the acceleration that she will need at the end of the slide using the variables we already know. The initial velocity being 19.7 meters per second, the final velocity being 5 meters per second, and the distance she has to travel being 50 meters. We can find the acceleration using this equation. We found the acceleration she would need at the end of the slide would be negative 3.63 meters per second per second. Now that we know the acceleration, and like the movie said her mass was 136 kilograms, we can use our F-net equation to figure out what the coefficient of kinetic friction is. The coefficient of kinetic friction that I found was 0.37. The coefficient of kinetic friction is only important to us if I can make one assumption, that a person entering an exit flume with about 15 centimeters of water is similar to two objects when they slide on top of each other. I can then compare coefficients of kinetic friction. And for this situation, 0.37 is too low. A coefficient of kinetic friction of 0.37 is similar to the coefficient between two pieces of glass sliding together, or mild steel on copper. Although these examples aren't necessarily very familiar to us, we know that 0.37 is very low on the scale because usually they range up to 1.0. Again, this proves even further how wrong the physics in the movie is because there's no way a person entering 15 centimeters of water could have a coefficient of kinetic friction equaling 0.37 meters or have a speed of 5 meters per second at the end of the slide to break the wood.